Okay, so right now I'm going to talk to you about proving statements involving angle relationships. Here's one theorem that we haven't discussed, but it's hopefully it makes sense. All right angles are congruent. That's the right angle congruence theorem. Okay, they're all going to be 90 degrees. We may use this at some point this year. Let's take a look at the first proof. As of right now, we know that line Q is parallel to line R. And they actually have the parallel indicators in there. That's our given. And then from that information, what can we prove? Well, maybe we start off by figuring out, well, what do we eventually have to get to? We have to prove that angle 1 and angle 3 are congruent. So what connection can we make right now? How can we possibly connect 1 and 3 together? We know the two lines are parallel, so we can actually say angle 2 and angle 3 are congruent. So let's go ahead and do that right now. Angle 2 is congruent to angle 3. And the reason we know that is that angle 2 and angle 3, they are in corresponding positions with those parallel lines. So I'm going to say if the lines are parallel, then corresponding angles are congruent. So if you have parallel lines, we know corresponding angles are congruent. We also know that angle 2 is congruent to angle 1, and that is by the vertical angle congruence theorem. Okay, so right now we've connected angle 3 with angle 2. We've connected angle 2 to angle 1 by vertical angles. So now we can connect angle 3 and angle 1 together. Angle 3 is congruent to angle 1, and that is by the transitive property. Okay. All right, next proof we have here, we know that angle 3 and angle 6 are congruent. So that's the first thing we're going to state here. Angle 3 is congruent to angle 6. That's given. We're trying to prove the lines parallel. And we know that angle 3 and angle 6 are congruent. So right now I can say that angle 6 is congruent to angle 7. Okay, because they're vertical angles. So you get the vertical angle congruence theorem. From there, in the given, we have 3 and 6 are congruent. We have 6 and 7 congruent. So that must mean that angle 3 is congruent to angle 7. And that's by transitive property. And if we know angle 3 and angle 7 are congruent, and those are corresponding angles, then that must mean the lines are parallel. So we're going to say line L is parallel to line M. And our if-then statement would be, since it's the angles that we know, we're going to list that first. If corresponding angles are congruent, then the lines are parallel. So that's what we know. Now we've done our proof. Maybe we want to connect what we can. So this angle 3 and angle 6 and angle 6 and angle 7, those being congruent led us to step 3. And ultimately step 3 led us to step 4. If we actually go back, connect our flow proof together, how did I know angle 2 and angle 3 were congruent? That was because the lines are parallel. I knew angle 1 and angle 2 were congruent based on vertical angles. That's not really connecting to anything. And then step 2 and step 3 connect. We're going to use both of those to give step 4. Okay, so now we're here. Let's see, we have two sets of parallel lines. And we're trying to prove angle 1 and angle 2 are congruent. Angle 1 and angle 2, They have nothing in common. I mean, they don't share a line. They're not located on the same transversal line. So there's really no relationship we can determine yet, but eventually, hopefully, we can determine that they're congruent. I'm going to start off with line L is parallel to M, and then we also have line T parallel to R, and that's given. Now, if line L and M are parallel, if this line and this line, if they're parallel, which can I use as a transversal between T and R that will have two angles located on that line, on that transversal line? That would be this right here. So if I focus on line L and line M that I've highlighted in blue as my parallel lines, so I'm starting off with this right here. Okay, if I focus on that, then I can state that angle 1 and angle 3 are congruent. So that's what I'm going to do right now. Angle 1 is congruent to angle 3. And the reason I can state that is angle 1 and angle 3 are corresponding angles. So if two lines are parallel, then corresponding angles are congruent. Now, that's line L and M. Let's focus on the other set of parallel lines, which is going to be line T and R. Is there a transversal line that intersects those two parallel lines that has two angles located on it? So I'm going to focus on this transversal line because it has angle 2 and angle 3 located on it. The two lines that I've shaded in blue here, that's T and R, they're parallel. We know that from the given information. And with the transversal line M, we know that angle 2 and angle 3 have to be congruent. And they are going to be congruent by what property? So you're thinking about that. Angle 2 and angle 3 are congruent. And our if-then statement would be if two lines are parallel, I'm going to just abbreviate parallel, then what types of angles will be congruent? So angle 2 and angle 3, where are they located? Those are alternate interior angles. So then alternate interior angles are congruent. Okay, so as of right now, we know that angle 1 and angle 3 are congruent. We know that angle 2 and angle 3 are congruent. So I can go ahead and say that angle 1 is congruent to angle 2. And that last step is the transitive property. Let's go ahead and connect my flow proof together. This led to this. This led to here. And then steps 2 and steps 3 led to step 4 together, forming the transitive property. Okay, this is a similar proof. First thing we're going to do, given information, Q is parallel to R, P parallel to T. If you're watching this video and you want to pause it to try to figure out how to do this on your own, that would probably be a good idea. We have the given information here. So if we have Q and R parallel, what does that lead me to determine? Q and R being parallel, that would be this line and this line. If I have P is the transversal line, that must mean that angle 2 is congruent to angle 3 because they are in corresponding positions. So our reason, if two lines parallel, then corresponding angles congruent. Okay, 2 and 3 are corresponding angles. These lines are parallel, so I can say they're congruent. Now let's focus on the other set of parallel lines. That would be P and T. So here's P and here's T. Is there a transversal line that crosses through line P and T, well, that would be this line right here. That's line Q, or yes, that's Q. What two angles are located on line Q? And then we're going to use P and T as my parallel lines. That would be angle 1 and angle 2. So angle 1 would be congruent to angle 2. And that's because they're alternate exterior angles. So that would be step 3. Angle 1 congruent to angle 2. The reason, if two lines parallel, then alternate exterior angles are congruent. Last step here, 2 and 3 are congruent, 1 and 2 are congruent, so that must mean that angle 1 is congruent to angle 3. Now there's the transitive property. Now let's connect our flow proof. That's connecting here, here, and steps 2 and 3 goes to step 4. All right, this is most likely a proof that's going to trip you up, because right now we do not have 2 pairs of parallel lines. We have 1 pair of parallel lines and 1 pair of congruent angles. We have to prove the other pair of parallel lines are congruent. So we're trying to prove, or not congruent, parallel. We're trying to prove that P and R are parallel. All right, so first, G is parallel to H. And angle 1 is congruent to angle 2. And that's our given information. Based on the fact that G and H are parallel, that's going to help me prove that angle 1 and 3 are congruent. So I'm going to say angle 1 is congruent to angle 3. The reason, if 2 lines are parallel, then angle 1 and angle 3, they're in corresponding positions. So then corresponding angles must be congruent. Let's see here. So right now, all I can do is connect. I know 1 and 3 are congruent because G and H are parallel. Can I use the first step here and the second step here? Oh, I almost sneezed. The second step there to prove something. So 1 is congruent to both 2 and 3. Hopefully we've done this property enough, the transitive property, that you know that angle 3 must be congruent to angle 2. So you're looking at angle 3 here and angle 2 here. Most people will say the reason those angles are congruent is because of alternate exterior angles. But you have to understand that we do not know yet that P and R, we don't know if those 2 lines are parallel. We have not determined that yet. That's what we're trying to do. So if we don't know P and R are parallel, we cannot assume that angle 2 and angle 3 are congruent based on alternate exterior angles. But if you look at our proof here, because we already know 1 and 2 are congruent and 1 and 3 are congruent, we can determine 3 and 2 are congruent, but it's because of the transitive property. Now that we know 2 and 3 are congruent, those 2 angles, we can assume that P is parallel to R. And our reason is, if alternate exterior angles are congruent, then 2 lines are parallel.